Graphing doesn't always help us get an answer. For example, if we graph two linear equations from a system, we see here in this example, it's hard to read that common point for a solution to this system of linear equations. Is it -2.5 or is that -2.6? How high is that y coordinate? So we have another option for finding a solution to a system, and it's known as the substitution method. It uses algebra instead of graphing and is thus considered an algebraic method. So here's the basis of it. We have two linear equations, a system that we want to find a solution. Since y in the second equation is equal to 3x minus 1, and we have a y in the first equation, we can substitute the y in the first equation with what y is equal to in the second equation, transforming our equation into the following. Instead of x plus y equals 7, as the first equation originally was, we have replaced y with its equivalent value given in the second equation. What this has done is given us an equation with one variable. We now can simplify and solve for the variable. Combining like terms gives us 4x minus 1 equals 7, adding 1 to both sides, and then dividing by 4 to solve for the variable, we find that x is equal to 2. This is the x-coordinate of the point of intersection or common point and the solution to these two linear equations. We're not done though. We need to replace x with 2 and find the corresponding y value so that we have our ordered pair and the point common to both equations. 2 can go in place of x in either of the two equations. We've replaced it in the second equation, and simplifying, multiplying first and then subtracting results in a corresponding y value of 5. That then concludes the problem and tells us that the common point or the solution to this system is the ordered pair 2, 5. Here's another example of two linear equations that we're looking for a solution. Solving it algebraically using the substitution method, we have x by itself in this first equation, and it's equal to 3 minus 2y. We're going to use substitution then for replacing x in the second equation with its equivalent value given in the first equation. So x is going to be replaced with 3 minus 2y. What this has done has eliminated the second variable. We now have an equation all in one variable. Following order of operations, we'll use distributive property, distributing -3 across each of the quantities in the parenthesis. Combine like terms next. Y plus 6y is 7y. And last, add 9 to both sides. To have y by itself, finally with a division, gives us a value of 2 for the y coordinate. This is indicative of a solution to these two equations. If we graph them, we would find that they intersect and have a common point, but we're not done. This is only the y coordinate. We need to replace y in either one of the equations. It'll be easier since x is by itself to replace it in the first equation, but it doesn't matter. Simplifying then to solve for the corresponding x value, we'll multiply and then subtract, finding the corresponding x value of -1. Putting these together, we have a solution to this system of -1, 2.